The instructors, I believe they give us a lot of insight and knowledge. They're just willing to give us any day of time to help us and to provide us with any type of help that we need during office hours, during class time, or during after class.
This college can provide opportunities for students who otherwise might not have them, not necessarily because they couldn't do the work or they're not smart enough to do the work, but because they may get lost at a larger school. And what students want, we can provide for them, and that doesn't happen at many places.
They're always making me work harder or take on a heavier load, and they're always, trying to push me forward.
We're obviously doing something well with the content that we're giving them, so that plus these sort of professional skills, I think, are going to only lead to us having successful grads.
They just test us, test our brain, test our knowledge, and it really prepares us.
I was here to teach, to mentor, and to provide advice. So that's what I love. I absolutely love doing that. I absolutely love watching my students succeed. I can't imagine doing anything else.
So, we're all here for you to get some information about the engineering process, specifically today for the research and development and cost analysis. He is a electrical engineer.
Yeah.
He is part of that research and development process and cost analysis at Kalo. And he'll introduce a little bit about Kalo and introduce a little bit about his job and how they go about the research, development, and cost analysis process. Thank you for your attention.
Thank you for having me here. This is probably the first time that I've been able to speak to a high school group, so if you'll bear with me, and if you have any questions or if I'm getting boring at any time, please feel free to nod off or raise your hand, whichever the case may be, whatever the mood moves you. First of all, let's kind of get an idea as to who I am. As you can see from this list of years on here, I've been around as long as your grandfather, so that gives you an idea how old I am. Presently I'm working, as Joe said, with Kalo Technologies. I've been there for about 6 years. Prior to that, I spent 6 years in retirement. You may wonder, why am I going back to work? Well, sometimes you find yourself wondering why you retired, because what I like to do is to do engineering work and in an industrial environment. So I was kind of lost when I retired, and I decided, well, I've got to get back to work. And so I looked around in the newspaper, found nothing, and then a friend of mine told me about Kalo, and I decided to go back there and do an interview, and fortunately they had some work for me to do, and I've been there for about 6 years. Prior to that, prior to my retirement, I spent 1 year working for my son in construction. Now, if you can imagine, no, you can't. You can't imagine working for your son, so I won't try to get into that too much. It's a very strange relationship. And then 6 years prior to that, I worked for a company called Timekeeping Systems in Cleveland, Ohio. We built security systems, guard tour systems. If you are aware that guards travel around their sites, their industrial sites, and they have to check, make sure doors are shut, nothing is out of place, and so on, and they have to record when they've been there. We built systems that would take care of that. I worked for 1 year, actually 2 times, I worked for Gould Medical, and working on some of their systems there. I worked as a contract engineer for them. 6 years I spent with DCOM. We did computer peripherals. That was a very interesting time. I worked on the hardware. I had 2 other engineers that worked on the software for those systems. And I spent 3 years at Allen Bradley prior to that. Allen Bradley, as you may know, you may have heard the name. They build electrical fixtures, big boxes, big contactors, and controllers that are used for controlling industrial processes. I spent 4 years at Picker International. Worked on the first CT scanner and the first MRI scanner that was used there as their medical division. I was involved with the computer side of that. I built the interfaces for the computer to the scanners. And then I spent 17 years at Dartmouth College. And you wonder, why did I spend 17 years? Most people could do it in 4. Actually, I was employed at Dartmouth right out of the Air Force. And I worked for them in the physics department doing research and building equipment for them, designing electronic equipment, and so on. So that kind of gives you a handle on it. 1 year at a TV shop and then 4 years in the Air Force, where I went to electronics school. We've come a long way in electronics. Anybody have any idea what that thing is? I thought probably not. That's an operational amplifier, and it has vacuum tubes in it. And if any you know anything about vacuum tubes, they take a lot of heat, they generate a lot of heat, and are not very stable. This is a circuit that I designed. I own a '66 Mustang, and I was looking at all the new Mustangs, and I said, "Oh, they've got lights that the taillights that flash. When they put on the directional things, they go blink, blink, blink." I said, "That looks like fun." So I built this PC board, and on here is an operational amplifier by today's standards, and that's pretty large compared to what you can get. So that kind of gives you a bit of background into what I do. Now let's talk about Kalo. Kalo is a company that's located in the industrial park in Clarendon near the airport, and we're a contract manufacturer. Contract manufacturer works for other companies. We contract with them to build a piece of equipment that they have. Most of our business is done with a company called Sealed Air. You're all probably aware of Sealed Air products. If you've ever gotten a package in the mail that contained bubble wrap, that was probably made on one of the machines that we make, the bubble wrap. If you look on it, if you look on the bubble wrap, if you're ever curious or anything, you might see that it says Sealed Air. There are other companies that do it, but they are probably one of the largest companies. And we build the machines that actually do that. I'll show you one of those a little later on here. We have about 50 employees at Kalo, and it's a very good atmosphere to work in. That's one of the things that impresses me. Everybody seems to get along quite well with each other. There isn't a lot of politics going on there. Sales are about $12 million a year. That translates to about $1 million a month that we have in sales. And we have a profit sharing plan with that, a bonus plan, if you notice there on the bottom line. Part of the profits each month are divided up among the employees, depending on your salary and your rating among the other employees. Each employee gets a rating sheet. He rates all the other employees in the company. So this kind of makes everybody want to work together well with other people. So people try hard to do a good job at what they're doing, because that's going to affect their bonus at the end of the month. How is the company organized? Okay, there's a number of things. I won't spend much time here, but there is always a management group that takes care of that, the president and vice president. Finance, we have a lady that takes care of that portion of it, a receptionist we have in there. The engineering department is comprised of 5 people. We have 2 electrical engineers, 2 mechanical engineers, and our supervisor, who is also a mechanical engineer. Purchasing, they take care of all of our buying. We buy parts for anything for production. They're involved in that. They're taking over more of that for engineering as well. We used to do a lot of our own purchasing, but we're getting so that purchasing is now taking care of a lot of that aspect of it. Manufacturing, that's a very important part of our business. That's the part that makes the products that we sell. So there, we try to make it in engineering as easy for manufacturing as possible. We provide all the documentation that they need, how to build a machine, the build procedures, and so on. And we try to make it as easy as possible for them, because otherwise we're going to have to build these machines. So it behooves us to make good documentation. Sales, obviously, that's going out and looking for new customers that we can do our work for. Shipping and receiving is in the warehouse. They're the ones that bring stuff in, inspect it. In the receiving, make sure that what we ordered is what we have in our shipment. And then we have product support, which all of our parts that all of the products that we make, we support them in the field. So we have to have a department that takes care of that. Okay, getting down to products. This is our main product right here. This is called the Cyclone. And what it does, it makes bubble wrap. Now, what you're seeing here in the machine, it also makes pillows like you see here. And if I point a few things out here, a picture here that's sealed across there, so it makes a pillow. And then this blue area right here is where the air gets blown into it to blow it up. And then this wheel here has a heater in it that seals that edge, so it makes a pillow. So that's our main product. We build it in an assembly area, and as you can see, they start from this end here, right down. I'll get my arrow here. Right down this end here. Start putting the machines together, and works down the assembly line. Each person doing it, and it finally ends up in final assembly. Okay, we lost electricity, I guess. Ends up in final assembly, and then final test, where one of the engineers, that's his job. He does all the final testing on each machine. As you can see underneath it, it has a sample of the bubble wrap that was made with that particular machine. So the paperwork and that bubble wrap is kept with that machine through final test. What happened here? From there, it goes out into the warehouse for packaging and to be put in inventory. We have this stack system in the warehouse that takes the boxes that these are packed in. These are all lined up, getting ready to be packed. Puts them on here, and then it's a motor-driven rack system that takes them in on this end, and they go out on the other end. So it's a first in, first out kind of system. Okay, now let's get down to the nitty-gritty of what I came here for. We'll call it Engineering 1. I won't call it Engineering 101 because we're not going to have more than this one day. So Engineering 1. In engineering, we come up with an idea, or our sales department has a customer that has an idea that they want us to do. So together with that and with the necessary tools that we have, the CAD systems and so on, we have SolidWorks, which is a mechanical CAD system. We have electrical CAD and Eagle software that we use for our electrical CAD. And whenever we do any project like that, we get together a team. Maybe one of the electrical engineers and one of the mechanical engineers, or depending on what the mix is for the project, it may be two of the mechanicals or two of the electricals. So it just depends what the mix is for this particular project. But we have a team that works together on the design, and that involves perhaps in the case of a panel that we just got through building for a company over in Denmark, we had to design the cabinet that it went in, and then I had to design the panel, the electrical panel that went in that. So we end up with a product, and then there's always at the end there's some waste. So you have to figure out what you're going to do with the waste. How is that going to be taken care of? So Okay, engineering principles. We want to get into the meat of why I'm here. First of all, there has to be a need. The first thing, a customer comes into our building or into our business, and they have a need. They want something built. They want something designed, perhaps. And then perhaps they've done the marketing on it. Perhaps we do the marketing to find out what volume we're talking about here. What is the price range that this product could sell in? And so those are the kind of things that we need to find out from need. Then we have to find out, is it designable? What they have an idea for, is it possible for us to design it? We have certain limitations in our company. We don't try to do everything. There are some things that we do really well. We have the skills in-house to do those. And so we have to decide, can we even do this project? And if we can, then we have to find out, is it manufacturable? Can we make it in the volume that the customer wants to get? And then the packaging. We have to put this into some kind of a package so that it can be shipped to the customer. In some cases, it's shipped on a pallet. We build up around on the pallet a box around it so that it's well protected, padding put in there, sealed air bubble wrap is probably used in there most often. And then now that we've got all these things in there, we found out is manufacturable. We found out how much it's going to cost because we have a bill of materials that we've developed. We've found out how much manpower it's going to take in production. And then how much is the packaging going to cost? And is that going to make it affordable? We have to make a profit. Probably the customer that we're building it for is going to resell it to his customers, and he needs to make a profit. So is it competitively priced? Is this going to be something that will fit into the marketplace for that? Going back to need here, one of the things that we need to be very careful about is make sure we understand what the customer wants or what the customer needs. If you start up in the upper left-hand corner, this is how the customer explained it. The next one shows how the project leader understood what was being said by the customer, and how the analyst designed it, how the programmer wrote it, what the beta testers received for the sample, of course, how the business consultant described it in glowing terms with a sunset in the background, and how down in the next row, how the project was documented. In this case, not very well. What operations installed, all they got was a rope, but the customer was billed for a very fancy system. And how it was supported was probably based upon how much documentation there was, and what marketing advertised, but this is what the customer needed. He didn't need anything very fancy, he just needed a rope and a tire. So we have to listen to the customer. We have to make sure that we understand what it is. Going back to designability, is it designable? Here's some items that I've picked off the internet that I found perhaps aren't too designable. If you follow the lines down from here, you find it ends up in a rod. That looks good. But then you find this one doesn't work so good, and this one ends up in space. So this is one of those things you can draw a picture of it. You could probably even get it onto a CAD system, but you can't build it. It's not something that's designable. Same with the triangle. If you look at that, you'll notice that that's there's not a conceptual way of building it. Manufacturability. Okay, you've got this thing designed, this cabinet, this electrical box, and so on. Now what? Can we manufacture it quickly? The importance for manufacturing something quickly is so that we can reduce our inventory. If you can think about bringing in all these parts that you wanted to build it with, and then it's going to take you 6 months, all that money that you've purchased the parts with is tied up in inventory. It's not making you money at all. You're not getting anything out of it. The idea of running a business is to turn that money around so that you can then sell it and make money off it. If you're going to have to wait a long time for your money, you're probably not going to make any in the end. Can it be manufactured in large volume? If the requirement is that we have to build a large number of these, then we're going to have to be able to manufacture it. We have to have a floor. Welcome. We're going to have to manufacture a lot of these in high volume and produce them in a way that we can handle. And we have to make sure we have the manufacturing space to do that. So that's part of quoting the job that the customer comes in with. And is quality going to be compromised? Are there reasons for that we can't build the best widget, whatever it is, that is possible? And is it going to be economically competitive? Are there people out there that are already making a similar product, and are they pricing it in such a way that we're not going to be able to compete with them? Okay, now we're getting down to where we're designing the product. We've decided we can do this job. Sales has written up a contract with the customer, and now we get to design it. So we have an engineering team. We have both mechanical and electrical, as I said. We have the tools and power tools, shop, hand tools, so on, on hand to do that. We have the specifications that the customer signed off on the contract, and we have management support. We have the personnel, and we have other resources. Perhaps we have to buy some tools to be able to do this particular project. Now, the time constraints, as I mentioned before, are very important, and we need to set up a schedule for doing this job, and then we'll have deadlines that we have to meet. We can't just let it go on forever. We have to keep within our time constraints, because time, as you probably have heard, is money. I earn a certain amount per hour. The company charges a certain amount for my time each hour. And I can't waste the customer's money taking too long on a project. Again, the cost constraints we have are determined by whatever the consumer pricing is, and we have to be able to stay within those constraints. And quality requirements, which we get from the customer's specifications, are things that we have to pay attention to. We have to make sure that we're doing a good job in keeping the business, keeping the product within those specifications. Okay, there is a quandary in engineering, and part of that is determined by this triangle. There's high quality. Obviously, that's what you want. You want to keep the costs down, and you want to deliver it quickly. Well, there's a axiom in engineering that you can have 2 of these, but you can't have 3 of them. In fact, you can have any 2 you want. Pick 2, you can have any 2. You can't get the 3rd one. And that's probably a pretty good axiom. And we have to be able to fit within that and decide how much of that 3rd one can we continue, can we perhaps cut corners on a little bit. You can have high quality and low cost, but you can't get those quickly, because the low cost to get the high quality is going to take your time. You can't have low cost and get it quickly and then expect to get high quality. And you can't have it quickly and high quality. Low cost is not going to be very easy to do. Okay. High quality goals. Obviously, you would want a product to have good quality. You want it to meet all the customer specifications. In fact, you'd like it to exceed the customer specifications, so he is extremely happy with what he gets. So we need to define the project very well. We need to know what our team's strengths are. Different people have different skills. My skills are in hardware design, software design, working with basic and basic programming language, basic compilers, cross compilers. Dale, who's my cohort there, he's the other electrical engineer. He's good at programming programmable logic controllers, PLCs. He's very, very good at that, and that has quite a background in what Picker has been, is a good part of the background of what Picker has been doing over the years. And so he's very good at that. And we cross talk a lot, just so that we know what the other one is doing and what those skills are that we can use, and pick each other's brains over that. So once you know the team's strengths, you can assign people to certain tasks on there. And then you do a very careful design. That's probably the most important part of it, is working very carefully, keeping your errors as few as possible so that you don't have to do a rerun on the design. We use the best parts that we can available. If you're going to go for high quality, we don't cut corners on that. We have multiple design reviews. In other words, we meet together with the other engineers and go through the design, pick it apart, and see what can be improved, what perhaps is wrong with that design. And then we document it very well. Every step of the way, we document what we've been doing. And that's very time consuming. Takes a lot of time. Perhaps half of the time or more is spent documenting what you're doing. So the costs of high quality means you're going to have a long design cycle with all those tasks that I just mentioned. You need to have prior knowledge of the personnel involved, and you need to check that design at every step, as I mentioned. You're going to be building it with probably the most expensive parts or expensive parts. And because of all of this, you're going to have a long time to market, and so high cost is passed on to the consumer. Low cost goals. Here we limit the project planning. We don't try to do as much as we can. We limit the personnel. In other words, if we don't put 2 people on it, if we can do it with just 1, that cuts down on the cost. We limit the design time. We keep project reviews to a minimum, and we design with less expensive parts. If we can find something that costs less, we use that. And that's one of the goals that we have, because we're in a market that's competitive. There are plenty of other people out there that would be willing to sell something. In fact, we're competing with Chinese manufacturers. As you probably well know from shopping at Kmart, most of the things you buy there are made in China. And it's no different in our business. But we have to keep our designs low cost and try to keep, so we have to balance off high quality with the low cost, keeping documentation to a minimum. Product quality, of course, tends to be compromised there, and the consumer cost, but the consumer cost is reduced. Sales and market shares, our potential is higher, because if we can produce a product that is less expensive, we can market it in a larger market. And the profit margin is potentially higher, because we've already reduced the cost of it. We can sell it at a margin that allows us to make more of a profit on that particular one. Quick goals. We want to get the product to the market sooner than the competition. That's one of the main goals of that. And also, the sooner we get that product to market, we're going to increase our sales for this quarter. And guess what? that fills my pocket because that's where the bonus check comes from those sales and profits for this quarter. Quick results. The lower quality is going to be less competitive because of quality. It's more competitive because of price, but it's less competitive as far as quality is concerned. Less design time, less documentation. Now this works on some products that you can do it with minimal amount of documentation. Because we have to order parts, we probably have to get them in overnight. That means we're going to have high shipping costs. We're probably not going to be buying in high volume, so we need to bring in our product or our parts at a higher price. If you buy parts, you get 10 of them, you get a higher price than if you bought 500 of them, say. And it's less time for researching parts. I can't sit down and spend all of my time trying to find a part that is less expensive when I need to get this out the door. Okay, now getting down to your project. I assume that this is what you're going to be doing. Am I correct? Okay. Green cleaners. You're going to have bacterial cleaners, a glass cleaner, and a hand cleaner. Okay. In order to do that, you've got to do many of the similar things that we do. You need a management team. You need leaders on that team, and you need to identify people who have those skills. And you need to assign those people to a particular role, and you need to delegate authority, people who can delegate authority. So, you need people who are good at finances, because you need to buy things. They need to be good at planning. They keep an eye on expenses. There are some people among you probably that just love finances. I don't, but I'm sure there are some of you that do. And then you need to maintain records to see how much this is going to cost, because no matter what you make, it's got to be something that can be sold and be competitive in the marketplace. Okay, what kind of people are chemical engineers, or any engineer for that matter? I just put this down because this is what you do. They're inquisitive. They have an innate curiosity about things. When I was in junior high, I was always taking things apart. I have radios, pieces of radios laying around my room. I had watches that I took apart and couldn't figure out how to put back together. And it was this innate curiosity that I had about how things worked and how could I make it work better that drove me. Can-do attitude. Don't give up. You know, that's one of the things about being an engineer, is you have to have an attitude that you can do it. It can be done. And that's very important. The other thing is persistence, is keeping on with whatever you're doing and being sure that you can continue doing it and making forward progress. And knowledgeable. It may be that what you're learning in the classroom isn't going to be enough. You may have to sit at your computer and look over the internet and find out how to go about doing something. I do that all the time. I mean, I started out in business making things like this. I didn't make this, by the way, but things similar to that with vacuum tubes. If I'd stopped learning when I got out of the Air Force, I probably would be slinging hamburgers at McDonald's today. By the way, McDonald's wasn't around when I got out of the Air Force. That gives you an idea how long ago that was. And you have to be able to work well with people on a team, because there are many tasks that need to be done, and you need to get along with all the people that are on your team. Which brings me to a parable that I think you might be interested in. In order to tell this parable, I'm going to have to revert back to a Vermont accent, which I've been kind of suppressing for most part of this talk. It involved my grandfather. My grandfather was a farmer, lived on a dirt road. Up that dirt road, he had a friend who he knew quite well. And so one spring morning, my grandfather decided he'd go down to town. And he looked out the door and he saw that it was warm out. And of course, you know, the first thing about getting out on the spring roads in the springtime is that they are muddy. So he says, I can't go down the road like that. I have to find some way of doing this. So he went in his shed, found a pair of snowshoes. He strapped on his snowshoes and proceeded to walk down the muddy road. As he was walking down the muddy road, he saw a hat laying in the road as he approached town. And as he got closer to the road, closer to the hat, he noticed that it was moving ever so slowly. Well, this got my grandfather's curiosity up. Being innately curious, he walked over to the hat and picked it up, and there, under the hat, was his good friend and neighbor, Walter Wheeler. Walter, he says, you are in trouble. Walter says, no, Rob, I'm not in trouble, for I still have my horse under me. Now, what can we learn from this parable? Absolutely nothing. But you can see Walter Wheeler was very persistent, and my grandfather was very curious and very inquisitive, very knowledgeable. He knew that in order to get down that road, he needed some help. So there's all those attitudes that are working into that story. And I think we can call that the end. Okay. Now, are there any questions that you might have?
Does anybody have
Any questions?
where the bell rings anyway?
Yeah.
Yeah, actually.
Yeah. Wait a minute. Wait, could I have your attention, please? Okay. What do you do if the people aren't doing the work? You give them a 1 on their rating sheet, and next quarter they pick it up. Yeah. No, you don't need to. Incentive money is a great incentive. Being liked by your fellow employees is a very important thing. And so if you work for a company that has profit sharing and employee ratings, you tend to find perhaps somebody will be not so cooperative one month, but they get the message or they're out of there. And that happens. I mean, the people that can't work with other people are not there anymore. About 2 months down the road, they find out they're not getting part of the profit sharing. Yeah, it's a great incentive. The other part of that equation was Kalo was a employee-owned company up until a couple of years ago, and I've been working there now for six years. And when we sold the company, each person who was part of that profit sharing earned a sizable check. Let me put it that way. It was much larger than what I had figured on. So if you get a chance to join a company that has either profit sharing or is employee owned, it's a great incentive. Yeah. Thank you very much.